welcome. This is Helidon Nima Loom-based microservices framework talk. I'm glad to see all of you here. My name is Dmitry Kornilov. I am Director of Software Development at Oracle, and I am actually managing Project Helidon. And also, you might know me because I am participating in Jakarta and microprofile activities, leading a couple of specifications, participating in platform project, and working in several committees like steering, spec committee, and so on. Here are my contact details. I will upload my slides to SlideShare after the talk. If you have any questions, you can contact me by email or by Twitter. Right. So this is talk about Helidon, so let's get started. Who knows what Helidon is? Right, so there are people who know, thank you for that. There are people who don't know. So the plan for the talk is that I'll give you some background information, not much, just enough to kind of get your vision, impression what Helidon is. After that, I describe what the problem I was solving and how we're solving that. I will introduce you our solution to one of the problems, which is Helidon Nima. And at the end, I hope we have a little bit of time. I'll demonstrate you a small sample, mainly to see differences between reactive code and blocking code, how it looks like, and so on. Right, so Helidon. It's a Java framework for developing cloud-native microservices. It's from Oracle. It's open source, licensed under Apache 2 license, and you can, it's on GitHub, Helidon-IO organization, where we have all repositories related to Helidon, quite convenient. It's small and fast by design. It was created from scratch. And by design, it uses the minimum number of third-party dependencies. For some of you, it maybe doesn't matter. But for corporate employees, it's important because usually then you create an application, you need to get approvals for every single third-party library you use. And this is a legal approval and a security approval, so it's a hassle. So less dependencies means less work. And it also allows us to be close to JDK, right? So if some functionality is in JDK, we're not using third-party library for that. We support GraalVM native image since version 2, and they're quite proud that we implement microprofile too, and our native image support works with full CDI implementation. So we just took Weld, modified it a little bit, and wow, it works with native image now. And here is the website, so check it out if you need to know some more information. Helidon is not an application server. It's a framework, means that you are not deploy application to Helidon, you actually create application using Helidon. And if you created application using our project starter, which is on the website, which is generator for your applications, you can choose whatever functionality you want to include there, and so on and so forth. You will get support automatic in your Maven project to that packaging. Oh, I should point there, right? So by default, it's executable hollow jar. You can also produce JLink image, means that jar produced and together with customized Java runtime, which includes only functionality which your application requires, which is smaller and has a little bit faster startup time. And GraalVM native image means that this is your this is a binary for operating system you use. I talked a little bit and mentioned flavors. So flavors are, it's kind of, we have currently two different sub-frameworks with slightly different development experiences. Both of them are Helidon. One is called Helidon SE, and this is the reactive framework. Non-blocking, functional style. It's built on top of native. We have a reactive solver. It's a heart of Helidon SE, which is built on top of native. I will actually explain why we have these two flavors later. And Helidon MP is a microprofile and Jakarta EE implementation. Like Jakarta EE partially, right? We don't implement any profile. With Java EE-like, Spring Boot-like APIs, annotations, dependency injection. And look at the picture. So we made it today that Helidon SE is more like an engine used in a car, which is Helidon MP, means that Helidon MP is based on Helidon SE, right? Again, I will explain why when we talk about problems we are solving. Little bit of history. So version 0 and version 1 of Helidon released in 2018. It was based on Java 8, microprofile 3.2. We don't support it anymore. So version 2 has been released in 2020, basically 2 years ago. Java 11, microprofile 3.3, we still support it, and a lot of customers actually using that. Recently, summer, this year, we released Helidon 3, which is Java 17, microprofile 5. That's a big step forward because it's Jakarta packages, not JavaX packages. So we moved completely to Jakarta. It's cool, right? And the next version is coming next year. It's going to be Helidon 4. It's going to be based on, it's currently, we have alpha released on Java 19, but we hope that Project Loom will go GA in Java 21. So Helidon 4 will be based on Java 21. And it will use whatever microprofile version actually at that time. So I don't know that version 6 is coming, but next year possibly will be version 7. So I put here microprofile.next, so I don't know which version it's going to be. Right, so that's a quick introduction about Helidon. Now let's jump to goals and problems we're trying to solve. Basically, we want our customers to pay less, right? And to pay less means that Helidon applications must be efficient and performant, meaning that we would like to maximize the number of processed requests if you have a service, minimize the number of CPU cycles, use less RAM, and have a small disk footprint, because you pay for everything. More CPU, you pay more. More RAM, you pay more. Not big number of requests you need to scale, so you add in another VM, then pay more again, right? So would like you folks to pay less. And it's actually a challenging thing to pay less. Oh, this one, right? It's a challenging thing to pay less because they need to process requests in parallel, right? So theoretically, it requires 1 thread per request. And we are facing limitations of Java at that point because in Java currently, a thread, platform thread is mapped to the kernel thread, 1-to-1. And kernel threads are scheduled by your operating system, and they're quite expensive to create. They're quite expensive to block and expensive to switch context. So we need to find some solution to that problem. And actually, the solution is well known, and it's reactive programming, right? So reactive programming, what is that? Everything is asynchronous. So we don't wait for something to happen, it just happens in future somehow, right? And when it's done, there is a mechanism of callback function. So you provide a function, it's called, then your operation is done. There is a concept of back pressure. And back pressure here I have from Wikipedia, right, actually. So it's from liquid dynamics, that back pressure is resistance or force opposing the desired flow of fluid through pipes. But in software design, they can change it to flow of data through software. I find this nice definition on the internet. I think it's pretty precise, describes what back pressure is, but for maybe difficult to understand. So a good sample is that you're working in the factory and you have a conveyor belt coming with some parts, and you need to take a part and do something with that. Let's say, I don't know, wash it, right? And you are doing that, but sometimes it may happen that there are too many parts on the belt, and you just don't have, you're not fast enough to take and wash it, right? Then this is actually a back pressure. So you need to use some kind of strategy how to solve it. You can take one part, take it apart, and process it, wash it. Then there are less number of parts on the belt. It's called buffering. Or you can just drop it, and this is called drop-in, right? So anyway, back pressure exists, and you need to somehow handle that. And there is a specification for reactive streams. And here is the link, reactive-streams.org. It actually explains, it's a specification, so it explains all the stuff about reactive streams. And the purpose of that is, it's an initiative to provide a standard for asynchronous stream processing with non-blocking back pressure, right? It's implemented in Java since Java 9 with Flow API. And our solution to that, it's not general solution, but our solution is Helidon SE. So I showed you a picture with flavors, Helidon SE, Helidon MP. So Helidon SE is mainly the reactive stuff to make efficient, operations efficient, and Helidon MP is just using that. So what Helidon SE is, it's just a reactive framework. It uses event loop, a small number of threads used for requests. It implements microprofile reactive stream separators. So with one of the implementation implements that, like single multi-operators. We also implement microprofile reactive messaging. And actually, we added quite a few stuff here, like a reactive web client, reactive DB client, to work with databases, to call other services, for the reason that blocking frameworks, third parties, let's put it this way, and reactive, they're not really combined together, right? So if you are doing reactive application, you can't use blocking third-party libraries because it will just block everything, right? You can wrap it into your executor service. This is okay, but it's additional complication, right? So we added some useful functionality for our users. And the heart of that is a reactive web server. That's why I have Netty here, reactive web server built on top of Netty. So we have a solution. Is this solution good? No, that's a good question, because that's the only solution, right? If you have only solution, you don't have a choice, is it good or bad, right? It's not ideal, I would say, right? There is a better solution, and I'll talk about that later. And what's wrong? What's wrong with reactive programming? It's complicated, right? So doing everything asynchronously will lead to callback hell. You know what callback hell is, right? So a lot of callbacks, and you can't really track your business logic because it's kind of spread through classes, through methods, and it's difficult to track. So if developer who created that application can track that another one which comes to support it, I don't know, it may be problematic for him. So the code is difficult to read. And this is actually not so bad, because the worst is that the code is difficult to debug, right? I'll demonstrate it on the demo. So we have like a huge reactive streaming code, and debugger just skips it. Tick, 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 tick. You don't see anything, right? There are no stack traces, right? It's difficult to debug. And even worse, it's difficult to test for the same reason. So is it good? I would say it's the only, right? And there is another solution. And another solution is actually Java virtual threads. And it's available now. It's Project Loom, JEP 4.2.5. It's a preview in Java 19, so actually you can use it with a flag, enable preview in Java. And what it brings you, now there are two types of threads: platform threads, which is what we used to have, right? And virtual threads, that's the new stuff, right? And virtual threads are, first of all, they're easy to create, cheap to create. You can create as many as you want. Now, with reasonable limits, right? But it's cheap to create. They are mapped many to many to your platform threads, meaning that you can have thousands or hundreds of thousands virtual threads mapped to, let's say, 10 platform threads. And JVM actually does all the hard working in mapping them into a platform thread. And what's even more cool here is that virtual threads are cheap to block. You can block thread without any problem. Then you block it, actually underlying engine moves it from the platform thread queue to the memory. And when it becomes unblocked, it moves it back to that, the same thread, maybe to the different thread, right? So it's all hidden in JVM. You should not care about that. So it actually allows us to make our desirable thread pull request solution. And this is where we introduced Helidon Nima. So Helidon SE is our solution for Reactive. Reactive's our solution for reactive solution. And Helidon Nima is our solution for virtual threads. And what is that? That's the first, actually it is de facto first microservices framework based on virtual threads, right? And it's similar to Helidon SE from the functionality, but it's totally blocking. We've done it from scratch in cooperation with Java team. So they used us to test their implementation, and we used them to build a nice, fast, optimized implementation. So it was a really nice collaboration. Nema comes with a module called Nema Solver. So this is a pure web solver. It's nicely modularized, so you can use that artifact in your application to, if you need a web solver. And it also has some additional goodies like observability, other stuff. I'll talk about them later. And it's already available. Alpha 2 is released. Here is a website. You can read about that. And actually, Thomas Langer, who actually made author of Nema, presented it, or mentioned it, on Java 1 inside Java keynote, right? So that's quite a big thing. So let's talk a little bit more about how Nema works, so like a thread model, right? We use one platform thread per port. And we use 2 virtual threads per HTTP 1.1 connection. And we can actually use 1, right? So it's configurable. And HTTP 2 is more complicated. It uses 2 virtual threads per connection and 1 virtual thread per stream, right? So technically, your Helidon service, if it has many connections, creates a lot of virtual threads. And now I'll show you the numbers, performance. But before I show you numbers, there is a disclaimer, right? Because we are using Tech Empower benchmarks to measure performance. And we actually submitted our Nema things there. But then we prepared the test. It's still not been released, right? So we run it on one of our machines. And it's a Linux machine, latest Ubuntu, 9th generation i9, 8 cores, 16 threads, 32 gigs of memory. And the software used there, you can read it, right? So a little bit confusion here is that a different Java version is used because Nema requires 19 and other tests, they work on different versions of Java. But the results are quite cool. So this is a comparison with Netty. So black is Netty, orange is Nema. And plain text processing, we are a little bit higher. And JSON processing, we again a little bit higher, right? So it basically proves that Netty is the fastest possible reactive solution, reactive solver. That it's possible to use virtual threads to build a web solver which has a comparable to Netty performance. We're actually quite proud with these numbers. Right, so let's go further and talk about features. So these are features of the Nema solver. what we had Alpha 2, right? So what we have so far. This is a small list. It's going to be extended. So we have HTTP 1.1 with pipeline in both client and server. I just quickly go through that, right? HTTP 2, client and server is in progress. Means we started with that, not finished. gRPC, we have server done, and client we haven't started with it yet. We have WebSocket prototype, extension to connect other TCP protocols, and testing support. Testing support is actually quite important thing because like got to be testable, so we included some things to simplify your testing with our server. And these are the goodies, right? I said that it's a web server with some goodies. Right? Goodies are here. So access log, car support, you can use it to serve static content, tracing, both open telemetry and open tracing, health checks. More are coming, so we are going to increase that goodies stuff to be comparable to Helidon SE. So it's going to have fault tolerance, it's going to have metrics, other things. Right. So the next release of Helidon is going to have 3 flavors. These 2 the same, Helidon SE and Helidon MP. And it's going to have Helidon Nima. And look, I put the electric engine, so, and the car of Helidon MPs now has an electric engine. It means that we are planning to switch Helidon MP from Helidon SE core to Nema core. Right? So we'll have a car with electric engine. And we already have a prototype for that to just show performance, how it works. And the performance is quite cool, right, again. So this is the black, is the current Helidon MP, which is based on Helidon SE. And the yellow one, or orange one, is Helidon MP based on Nema. So we have twice much of performance. And it actually makes sense that originally, no, now we have like blocking on reactive, and we are going to have blocking on blocking, right? Which is better and more performant. Now, I don't know how much time I have. All right, so I have 5 minutes. Let's take a look at the demo. So there are 2 pieces of code. There's a split screen, right? Left side is the Nema code, implementing the same thing. And the right side is Helidon SE reactive code, right? So I'm showing to, so you see the difference. This is what actually Thomas Schlanger presented on Java 1. You actually see his name here, right? So this is his sample, it's not my sample, right? Right, so the first thing is sleep, right? Simple operation. So you just block the thread for 1 second. And it's quite straightforward in Nema, you just do thread sleep. That's it. And in a reactive world, it's actually quite complicated. I'm not saying that you should do that. I'm just demonstrating the differences in code, right? So this is quite readable. This one is sync and walk, and after that you have a try-catch block, and you need to handle errors yourself, and so on. It looks a little bit complicated to me. I'll skip just one sample. I'll go to sequence sample. And sequence sample is you pass a count parameter using your query string, and this line of code reads it. And after that, it performs count number of requests to some external service continuously, so 1 by 1. So again, this is a blocking code. Look, we have a 4 cycle, 0 to count, and we do our remote call. That's it. Easy. Everybody understand that. Reactive. We need to have a special operator called range. After that, we flat map it to make the remote calls. After that, we map it to collect requests. And again, we need to process errors. So this code is, I don't know, is it a little bit or quite a lot complicated to read? For me, it's definitely more complicated than that. And the third sample I have, and this time, it's the same as the second one, but we are doing remote calls in parallel, right? So we receive a count. If count is 5, let's put it this way, we do 5 parallel requests to some remote service. Again, this is a blocking code. We create executors with new virtual thread per task, so it will create virtual thread per every single task. We constrained futures with the remote call. And here we construct responses and actually call future get, right? And here it actually makes the call, right? A reactive code, no. To be fair, it was not created by me, and I'm not sure that I will be able to create that because it looks quite complex to me, right? So blocking code is definitely much more readable. Now, another thing I would like to show you. Let's just run it. So I'm going to start the debugger, running it now, and I'm going to have the stop point, breaking point here, and I am not here, calling that parallel endpoint with, let's say, count 3, right? So we're here. And you see that I'm going through, it displays everything. You see all the futures here, right? You can see what's inside, right? So everything is displayed. When we go to requests, or responses, sorry, here will be a small delay. It's when it actually makes a call. Here it is. So it's done 3 calls now. And you actually can, in debugger, see all the responses, right? So 3 times is going to be, right? Going to collect it, that's it, we're done. So all information in the debugger, you see everything, right? When I do the same with reactive code, let me just stop it. And I need to switch profile and debug it. Here is going to be a breakpoint. And I need to call this service. It's another port. Let's say count 3. Right, here it is. Look, we have only this request and response, right? Then we start to debug, gene. It just keeps everything. It doesn't change. You don't see anything there, right? No stack traces. So this is what I meant by difficult to debug. It's exactly that, right? It's complicated. Right? So here we are. Let me just switch back to my presentation. I think we don't have time already, but yes, but I need to go to here, right? So I'll just go through challenges quickly. And these are basically the challenges we faced when we were developing the Nema solver, right? So reuse or not reuse, right? Originally, we were reusing byte buffers because it was more performant. But in Nema, with a huge number of virtual threads, we found out that it doesn't make sense. And it makes sense to discard them and let garbage collection to take it. It's just faster. Another thing is asynchronous writes, right? So the sockets. It makes sense only if pipelining is used. And if pipelining is not used, it doesn't make sense, right? So we were experimenting quite a lot of that, and that's kind of what we found out. So there is an option in Nema to disable asynchronous writes. Blocking or not blocking socket channels, right? So basically, we did a lot of experiments with Java team and found out that actually using server socket in the old-fashioned mode is more performant. So it's used in a blocking way, and after that we create a virtual thread for processing. And the last thing here, which was a challenge for us, to get used to block. So we were writing a lot of reactive code, and blocking was considered bad practice, right? So blocking is bad. But then you work with Project Loom, blocking is actually good because it's cheap and you can block. There are some more challenges. I just didn't include it here. And that's it. So these are some contact information, our Twitter, our blog on Medium, our website, GitHub repository, YouTube, I guess we have YouTube, and we have a Slack channel too, so feel free to contact us. And thank you very much for coming. And do you have questions?
Well, thank you. So I've noticed in the sample to the left the new one, imperative, using the virtual threads. Compared to the old style imperative, it looks like you just need to create a different type of executor service at the beginning.
Yes.
So it's that simple, no other API changes we should be aware of, because I read about Project Loom, but I didn't look into the API. So new API, or essentially the same programming model, just a different entry point for creating the threads?
Right, so the question is that, is there the same API for virtual threads in Project Loom, right? Or there is something new? It's actually both, right? So you can work with virtual threads the same way as a normal thread, right? You create it using different static factory method, thread dot, I don't remember how it's called, right? And Project Loom actually comes with two things. One is virtual threads, another one is structured concurrency, it's what they call, right? So, and they provide different kind of, let's say, scopes, right? So I don't remember how it's called really, but you can basically work of these tasks. You create many tasks, and there are strategies that execute them in parallel and return the first successful, or execute them in parallel and return what failed, something like that, right? So I guess my answer is not really precise, right? And that's because I'm actually more on the management side than on the real code writing side, right? I hope it satisfies you. If it's not, feel free to, I can give you contacts to my folks who actually wrote Nema, and they'll be able to help you better than me. Please.
Another question. You said that virtual threads are very cheap. That means that they consume very little memory, in fact.
No, they consume definitely less memory than platform threads. Yes.
And another question, you don't need thread pools anymore with virtual threads, am I right?
I think so, yes. I think yes. Because you can create as many virtual threads as you like. You don't need to pull them. More questions? Please.
In Helidon 4, when using the MP kind of
flavor.
Yeah, flavor. Will we still be able to use reactive messaging, for example? Is it somehow connected to the old SE part of Helidon,
or not? Yeah. Okay. The question is that in Helidon 4, will users be able to use reactive messaging implementation from microprofile in Helidon MP? And my answer is yes. you'll be able to use that. More questions? Kenji, please.
Can you use the microprofile feature with Helidon?
Microprofile.
Microprofile feature or library with Helidon Nima.
A question is, can we use microprofile specifications or implementations with pure Nema, right? And my answer is no, you can't use it with pure Nema. We implement microprofile in Helidon MP, right? And when Helidon 4 comes, you'll be able to use microprofile implementations of Helidon MP, and it will be based on Nema, and you'll get not slight, like a twice performance. More questions? Okay, so we're done, and thank you very much for coming.